Okay, this is section 1.6, which is just like some extra rules that we'll need for differentiating. And it's been a while since I've used this notation, this d over dx. So if you go back through your notes, you will find that that means the derivative with respect to x. So it's nothing new, it's just been a while since we've seen it. So this first rule is the constant multiple rule for k a constant. So like, for instance, we kind of already knew this. Like if f of x is equal to 3x, then we could actually just do, if we wanted to find the derivative, we could not even worry about the 3 and just do 3 times whatever the derivative of x is, which we know is 1. So this is really not a new rule. And we'll do a couple more examples though in case you're not feeling all that comfortable with it. And then the next rule is also not that new. Basically, this one says if you're trying to take the derivative of two functions that are added together, you can separately take the derivative of each one and then add it together, or subtract it, whichever one. This one on the bottom, this one is new. We do have something like the power rule. Like we already know that if f of x equals 3x squared, then to take the derivative, we are just going to bring down this power and do 3 times 2 x to the 2 minus 1. So we do know that rule. That rule we already know, but this one is different. This one is saying that if there's an equation, something more complicated than in this problem where it's just an x. So this rule is saying that if it's a little more complicated than that, we'll do the same thing where we bring the power down and then we subtract 1 from the power, but then we're going to multiply it by the derivative of the inside. So we'll come back to this. This is a tougher one, so we'll do a couple examples like that eventually. But for now, let's do some easier examples and we'll just kind of build our way up. So for number 1, it says take the derivative of 5x to the 4th. So the first thing we're going to do is I'm going to bring the 5 outside because it's a constant and just do the derivative of x to the 4th. That was rule number 1. And then to do the derivative of x to the 4th, that's 5 times we bring the power down and then do 1 minus the power, or the power minus 1 is a better way to say that. So simplifying that, that's 20 x to the 3rd. And we just use the general power rule basically, just in its simplest form. Okay, so then we'll do the same thing again. So for this one, I'm going to use that first rule, the one about constants, and pull out the negative 3/7 and just do the derivative of x squared. So that was rule number 1. And then we actually know we have x squared memorized, hopefully by now, maybe. Okay, that was pushing it a little bit. We're going to take the derivative of x squared by bringing the power down, 2, and then 2 minus 1. So that's negative 3/7 x to, oops, almost forgot the 2. Okay, negative 3/7 times 2. And 2 minus 1 is just 1, so that's just an x. And then I'll simplify a bit. Negative 3 times 2 is negative 6. So we get negative 6/7 x. And right in here, we used rule number 3, the general power rule. So far, there hasn't been any addition, so I haven't used rule number 2 yet. Okay, so to do the derivative of this one right here, I'm going to, like before, pull out the constants that I can't pull out. 6/5 times the derivative of 1 over x cubed. And then a little tip here is it's always good to make your exponent be in the top. So for example, it's always a good idea to rewrite it 6/5 d dx, and then x to the negative 3 power. The reason why that's good is because this is something I actually know how to differentiate. One over x cubed, it's a little tougher, but x to a power, I know how to do that using rule number 3. So according to rule number 3, I'm going to get 6/5, and then I'm bringing that power down, x to the negative 3 minus 1. So I have 6/5. So I'm just simplifying now. And I just did rule number 3, so I'm going to circle it. 6/5 times negative 3. And then x to the negative 3 minus 1 is a negative 4. Or negative 6 times 3 is 18. So I've got negative 18 over 5. X to the negative 4. Okay, let me check to make sure I've got all my negatives in the right spot, because I have trouble with that sometimes. Yep, that looks good. Okay, so do the next one. All right, now I'm doing the derivative of a cubed root. So always a good idea to write things as an exponent. So I'll start, instead of pulling the constant out, I'm going to write that as x to the 1 over 3 all over 12. So that's just algebra. Then I'll pull the constant out, 1/12 d over dx, and then x to the 1/3. Okay, and I did use rule 1, so I'll circle that. Now I'll use the general power rule, rule number 3. So 1 over 12 times 1/3 x to the 1/3 minus 1. So simplification needs to happen. 1/12 times 1/3 x to the 1/3 minus 3/3. Just trying to add fractions here. So 1/12 times 1/3 would be 1 over 36. And then 1/3 minus 3/3 is minus 2/3. I'm done. Okay. So again, just to repeat this tip here, you never really want to work with a cubed root. It's just easier if you make it an exponent because we have that rule for exponents. Always a good idea to change it to a power. Okay, let's do this next one. Okay, so this is the first instance where we're going to do something we haven't done before with the general power rule. This is like an exciting moment. So the general power rule says basically if you have f of x equals, let's say h of x to a power of n, then, oops, I don't need to put that there. So if you start with f of x equals h of x to the nth power, then f prime of x is going to equal n h of x to the n minus 1 power, and then times h prime of x. So sometimes people get confused and they just keep doing the derivative like over and over again. So I think it kind of helps to outline what everything is. So in this case, h of x equals 5 minus x cubed. And n, so actually my h's and my n's look a lot alike. I'm going to start doing a capital H. So h of x equals 5 minus x cubed. N is the exponent, n is 7. So I need to find what h prime is. So h prime. So up above, the derivative of a constant is 0. So the derivative of negative x cubed is what I need. So that'd be a negative 3x to the 3 minus 1, or 2. So now putting it all together, f prime of x is what I'm thinking about in my equation, is n, which I know is 7, and then h of x, which I know is 5 minus x cubed, to the n minus 1, so 7 minus 1, and then times h prime of x, which I just found to be negative 3x squared. Okay, let's see how that works. Let me know if you have questions, because that's the first one that's really unique, like a new one. Let's try the next one. So for this one right here, this one we've got some adding in, which is great. So I'm going to rewrite this so that everything is x to a power. So this is just algebra. I want the derivative of 5 times x to the 1/2. That's how I rewrite a square root. And then I want to get the x cubed into the top, and I do that by doing a negative x to the negative 3 power. And then this last one is actually already in great shape. It's 3/17 x to the 5th. Okay, rule number 2 says that when I'm adding or subtracting, instead of trying to do this whole thing all at once, I can break it up into smaller pieces and instead do each derivative separately. So 5x to the 1/2 minus the derivative of 7x to the negative 3 plus the derivative of 3/17 x to the 5th. And then this is actually not bad from there. I can take the derivative of each one of these things. Let's see. So for the first one, I get 5 times 1/2 x to the 1/2 minus 1. And then minus 7 times negative 3 x to the negative 3 minus 1. And then plus 3/17 times 5 x to the 5 minus 1. There's a lot to clean up here, a lot of multiplication. That's the same thing as 5/2 x to the 1/2 minus 1 is minus 1/2. And then minus a minus, that's going to be positive 21. X to the negative 3 minus 1 is negative 4. And then 3 times 5 is 15, so I get 15/17. X to the 5 minus 1 is a 4. Okay. So in my steps here, I basically did rule number 1 and rule number 3, because I used constants and I also used the power rule to bring all the exponents down. Okay, this next one is also a power rule problem. So I'm going to write the power rule again. F of x equals h of x to the nth power. If that's true, then the derivative, okay, that was a very weird looking derivative. Let's try it again. F prime of x equals n h of x to the n minus 1 power times h prime of x. Okay, so then I'm going to try to define everything. H of x is the part in the middle, which is 17 minus 4x squared. And while I'm at it, I might as well take the derivative, h prime of x. Derivative of a constant is 0. And then for minus 4x squared, 2 times negative 4 is negative 8. X, 2 minus 1 is just a 1, or I could just leave it negative 8x. And then the power here now is tricky. So we have 17 minus 4x squared. To rewrite that as a power is going to be all of that to the 1 over 4 power. So my n in this case is 1 over 4. So now it's just a matter of writing it out. So f prime of x is going to be equal to n, and I'm just reading the equation, which is a quarter, and then h of x, which is 17 minus 4x squared, and then raised to the n minus 1 power, so 1/4 minus 1, and then times h prime of x, which is negative 8x. So I'll simplify a little bit. 1/4. 1/4 minus 1 is minus 3/4. So 17 minus 4x squared. 1/4 minus 1 is minus 3/4. And then times negative 8x. Okay. All right, I think we will pause right here. I think I might skip this problem right here because we've done quite a few examples. Might be a good time to move on to something different.